Good afternoon, students. It is so good to discuss and have this opportunity to discuss dimensional analysis in general chemistry. So just before we begin, this is going to be a short discussion in which I explain to you some concepts associated with dimensional analysis. Let's just go through a few quick ideas before I go through some explanations that are relative or related to your homework 2. So let's discuss read mode. Let me see. View full screen mode. There we go. So dimensional analysis. Let's just recap. Dimensional analysis and what we're looking at, especially when they talk about Planck's equation, E equals h nu or hv, however you read it, and de Broglie's equation, lambda equals h over mv, or Rydberg equation, whatever equation we're looking at. We are primarily looking at dimensional analysis, using dimensional analysis. So the solution is you look at the number of objects, you relate that object to one of those objects or the SI unit, then you multiply it by the desired SI unit divided by the unit or related unit. One more time, number of objects over 1 times the related unit over 1 object times the desired SI unit over the related unit. So let's go over this. You have the number of objects over 1. In this step, we use the number of objects given in the problem as the basis for conversion and solutions. What that means is we use the number of objects that we've been given in the problem as the basis from which we deduce the solution. For example, if you want to solve for the length of a group of hydrogen atoms, you have 6.02 times 10 to the 23 atoms over 1. In this step, we use a ratio. The ratio is represented as a fraction. It involves a unit that is related to the object we are aiming to better understand. For example, if we want to solve for the length of a group of hydrogen atoms. So you look at the number of atoms, 6.02 times 10 to 23, so that's 1 mole of atoms, times the length of one atom, 212 picometers per atom. Then we look at the step 3 is to multiply by the desired unit. So you want to convert the length of the atoms, you want to account for that or convert it into meters, which is the SI unit. So in this step, we use a ratio. The ratio is represented as a fraction. It involves a unit that's related to the object we are aiming to better understand. For example, if you want to solve for the length of a group of hydrogen atoms in one line, 6.02 times 10 to 23 atoms over 1, so that's 1 mole, times 212 picometers over 1 atom, times 1 meter over 10 to 12 picometers. That gives you 1.28 times 10 to the 8th meters. In the homework assignment, you would notice I have like example, I would say something like 1.28 E plus 8. What that's referring to in this context is it is the expression that shows an exponent raised to something, or 10 raised to that. So E plus 8 in this instance will be referring to, so if I rewrote this solution with that notation that you would see on calculators, I would rewrite it saying 1.28 E plus 8, which is the same thing as 1.28 times 10 to the 10. Correction, it would be 1.28 times 10 to the 8. Let me draw it back. Let me see if I can use annotation. There we go. So this right here, if I had 1.28 E to the plus 8, or E plus 8, that's the same thing as 1.28 times 10 to the 8. And just keep that in mind. So let's keep going. Let's keep going. Let's keep going. Okay. Okay. So we're not looking at derivatives today. We already discussed that. So let's work through some questions. I'm gonna give you general solutions to some of these things, not specific solutions, because that's your job. So what we're going to do is we're going to look at converting time, or converting distance rather, from the sun to the earth to time. And the equation we're going to use, you could use HT over lambda, but what we're specifically going to use is just a dimensional analysis framework or dimensional analysis setup. So we're going to look at the distance that we have in kilometers. That's the distance times 1,000 meters over 1 kilometer times 1 second over the speed of light, and that should be 3.00 times 10 to the 8 meter, and you see it's the reciprocal, right? Meter. So 3.00 times 10 to the 8th, that's going to give you some answer. Now it's your job to solve for that, given the values in the problem. So let's look at another question. Say we have asked to determine the de Broglie wavelength. The de Broglie wavelength will involve us looking at the de Broglie wavelength of an electron. Say we were asked, solve for the de Broglie wavelength of an electron. So the de Broglie wavelength, typically the equation is written as, let's just write the equation. Lambda is equal to H over mv. But this can be rearranged. This can be rearranged if you were to multiply, or if you were to, let me see. If you were to multiply, yeah, there we go. If you were to multiply this by v, multiply both sides of the equation by v, whatever you do on one side, you do on the other. Multiply both sides by v. That on the right hand side cancels out, so you're now left with lambda times v equals h over m, and then you divide both sides by lambda, and that's divided by lambda, and you get that the lambda on the left hand side cancels out. That gives you v is equal to h over m lambda. That's the de Broglie equation. Let me erase that so it's clear. Equals, let me see, draw, equals h, actually not, that's not what I want to do. X. Actually, no, that's not what I want to do either. Let me see. X. Let's see. I'll take H over M lambda. That's that. Let me draw it clearer. H over M lambda. Wow, that's that. So that's what frequency is equal to. H over M lambda. So that's what this is saying here. To rearrange the Broglie equation, rearrange. So here you have Planck's constant, right here. This right here is Planck's constant, which is h. This right here is the mass of the electron dot. This right here is the wavelength, and then you have to convert that wavelength into meters. Always remember, you must use SI units, and then you get an answer. And I'm gonna let you do that because this is one of your homework questions. Also, let me erase. Just keep that in mind. This equation has been, you have to rearrange the de Broglie's equation to solve for the wavelength if you are given the mass and the wavelength. Now, if you solve for the frequency rather, or the speed, you have to rearrange the equation so that you are able to use the values that you're given. So the formula is basically a set relationship or an established description of the relationship between two variables. And what you're able to do with that formula is dependent on the, or what you need to do with that formula is dependent on the values that you're given. So just keep that in mind as you solve for the values in your homework sets. Formulas are basically descriptions of relationships. Whether those relationships are directly proportional, indirectly proportional, you have to determine that from reading the formula. So let's keep going. Now, that was the example of the de Broglie equation, and this is another example of the de Broglie equation. In this instance, you're given mass and velocity. Now you have to determine the wavelength. So this is an easy one. You have the Planck's constant, 6.626 times 10 to the minus 34 joule per second, or kilogram meter squared over second squared times second over the mass of the electron times velocity, and that gives you an answer. I'm not going to tell you what the answer is. This is your homework. So that covers all of the challenging problems from my understanding. If you have any questions, please email me. Happy to help during office hours. The homework is due September 4th. If you had questions, you should have reached out to me beforehand. Please note that the homework due dates are published ahead of time so that if you need assistance, you're able to attend office hours. Just remind yourself of that. Remember that you are not alone. This is an academic community. However, you are responsible to be, you must be responsible, ethical, and hardworking scientists. So just keep that in mind throughout the semester. All the best, and hope you have a good rest of your weekend.